Hi everybody, we are back and we're going to go through our Pset 7 solution videos. So we have a contingency table. We're trying to figure out basically what is our analysis essentially for this. So that was a horrible description, but actually, sorry, get that out of the way. So let's go ahead and let's analyze this. So let's bring this up in R and then let's figure out how we can do our expected values and all of our other good stuff. So first thing we're going to do, we're going to set up our basically data matrix. So we're going to do Control Enter, Enter here. I'm going to install everything here. We need to install that environmental stats. So that's going to get through here. I'm also going to open up, not attached, but I want to open up some of the former, actually, I want to get our expected values here. So we're going to open up lecture 8. And then open up that Mathematica. We'll get that going. We'll start to answer some of our other questions as we wait for environmental stats. So when we're doing contingency tables, we're basically looking at comparing TV shows and the candy that people enjoy. So people that watch Bones liked, Trolley, Supernatural, this, and then Reese's, Twix, et cetera, et cetera. So we're trying to compare, remember, if those variables are they independent of each other? So are the means equal or are they not? So are we in the reject or do not reject regime? So let's go ahead and get started. So I'm going to go ahead and set up the matrix. So we're just going to go 5, 36, 5, 36, 15, 2, and then we're going to break it up into each of these sections here. So set up the matrix, set up the number of columns, by row, set it equal to true. So data, set the matrix, give them column names, row names, and then we're going to set it as a table. And we're going to observe that here. You really want to double check and make sure that the table you've set up matches the table or the contingency table that you are working with as well. So let's go ahead. Are the variables independent at a 1% significance level? So what we're going to see is we need to calculate our p-value. So we can actually run our chi-squared test directly here. So, for example, we lectured, excuse me. So we're doing a chi-squared test in these contingency tables. And so we're going to see, are these variables interrelated? And then we're going to analyze that. So let's go ahead and we can run that chi-squared and we can calculate our p-values. And remember, we're looking at that p-value, or actually we're looking at a 1% significance. So we can go ahead and run through that. Now remember, what we're trying to see and test for is correlation between our variables. So are they dissimilar or are they not? So does it fall in the reject or the do not reject regime? Let's make sure that we actually know. And basically, is there a correlation between these two variables? So let's go ahead and we'll go ahead and start to run. Let's go ahead and run the chi-squared. So we're going to run the chi-squared test on this data. And it gives us a chi-squared value. It gives us the degrees of freedom, which is 6. And then our p-value is extremely, extremely small. So where are we? Or where are we here? Excuse me. Let's go ahead and look through here. And we can see that we are in where? We are definitely in the reject regime because our p-value is much, much less than this value here. So, and remember, it's a single-sided test. So, actually, right-tailed test, effectively, because it's a chi-square test. So there we go. We've got it. So we can go ahead and actually look, basically see that those values, those variables are, we're going to reject the null hypothesis that basically those variables are correlated. All right. So let's go ahead. Now, we've answered most of the questions. So we've figured out the total degrees of freedom. And that's pretty straightforward. Whenever we're calculating that, we can actually use the degrees of freedom is just going to be equal to our rows minus 1 times our columns minus 1. So what are the rows here? The rows are going to be 3, so it's 2. So columns is 4. 2 times 3 is 6. And we see here, we get that as well. But what are our actual, like the expected values? So whenever you're doing these contingency tables, if you want to calculate it by hand, which I wouldn't do, but you can, you want to basically take and calculate and add essentially the totals here. So the totals by row and the totals by column as well. So you just kind of sum and add those up. So we can do that. Unless it's always a good activity to run through. So we can basically do an expected value. And actually you could confirm your expected with your observed in order to double check your chi-squared value. So let's go ahead and actually do this for this first problem here. We may skip it for the other problems, but let's see. We can probably do this pretty quickly here. And this is already set up from our previous data set. So let's go ahead. And what we're going to do is we're going to, let's set this up. So it's going to be 5, 36, 15, 2. Then we're going to have 30, 15, 9, and 3. And then we're going to have 5, 4, 20, 20. Let's double check our data. And this will be, looks good. Yep, that's going to be our observed data. We are going to do our expected values. Oops, let's do it in terms of our, actually here, let's do it not in terms of, we need to do this a little bit more. Let's do this. Instead of 3, we want to make it a little bit more. Here we go. We're going to use this definition. So let's go ahead and do, what do we call this up here? Observed at, obstat. Actually, I'm going to call that obstat OBS. OBS is equal to that data. And then we're going to go down to here. These are going to be our expected values. Then we're going to go through here. 89.19. Oops, our values are a little bit different here. Let's double check this. The length of observed. Let's double check this. So we actually see here that there's a little mistake. Previously, I had a typo. I typed in 20 here. So if we type in 22, we can get that last value to match our totals, our expected, and then we can actually look up here. Actually, excuse me, from our R92.98. So perfect. We got it. So let's go ahead. Are the variables independent? We are in the reject H naught region. So boom, boom, boom. Let's go ahead and let's go through the next one. And we can double check. And you could run this same analysis now for the rest of these just to match. So I'm going to do one more. So 44, 5, 3. And then I'm going to go here and do 6, 8, 9. And then I'm going to do here, I'm going to do 7, 9, 9. So we should know that the degrees of freedom should be basically 4. Because again, row minus column 1, row minus column 1. So 3 by 3 should yield that. And I'm going to actually, let's go ahead and shift enter that. Let's shift enter this variable here. And then we'll shift enter our expected values, which are going to be generally stored here. And then generally here. That's a big chi-squared value, so I would expect that we have a very, very low p-value, but let's double check. We're going to go ahead and set up our theta. Looks good. Satisfied, 44, 6, 7, 5, 8, 9, 9. Good, good. Degrees of freedom 4, chi-squared 34, and p-value extremely small. That is going to be a reject H naught, and that's all we got. Fantastic. Let's go ahead and double check here. Remember that p-value is going to be very, very, very small, so we're going to be in the reject. Excellent. So let's go back to here. One more contingency table. We'll set it up again. Enter, 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 enter the data. We've got the data here. Let's do the chi-squared. Very, very large. All reject again. Degrees of freedom we can do rows minus column 1, and we've got it. And again, you can set up that to actually get the expected values as well. Fantastic. Now, what about when you maybe necessarily don't have the data and you have to do basically an F-test? So let's go ahead and see how we would approach this system. Does A come from a population with a variance of 3.9 seconds at a 1% significance? So for this problem, we're going to have to actually set up, a variance test here. So what we're going to do is we're going to have to look at a chi-squared. So we're going to do this chi-squared function. We're going to get a chi value, so chi-squared fun, and we're going to set. So for system A was measured 49 times. The standard deviation, or the S, actually the S, that's the standard deviation squared. Let's double check that actually. Yeah, that's S squared. That's going to be our actual measured standard deviation. Sample standard deviation of 1.8. And again, be careful. That's your standard deviation, not your variance. So be careful of the wording there. And your sigma squared, basically a variance of 3.9 means that we need to do square root of 3.9. Square root of 3.9, because variance of that. So we can go here, 1% significance. We get our value. That chi-squared is 39. So if we had to calculate it, we'd have to look at this here. So we'd have to look at basically your degrees of freedom in this system. And we'd have to look at basically this table here. Actually, we can look at this table here. Excuse me, we don't need to look at this. So we have our chi-squared value. So if we're looking at a chi-squared, what is our, if we're looking here at this system here, so our nu is going to be our number of measurements. So we can actually just say here that's going to be, let's just call it an infinity value. And number of measurements, and our confidence interval is 0.01. So let's go to our chi-squared table. And 0.01, so chi-squared theoretical of 50. So we're actually in the do not reject region in this instance. Excellent. Now, let's go to the next problem. Where are we at here? Actually, where's the problem? So do not reject. Does C come from a sample population? So let's go ahead. And actually, let's go ahead. Does C, which has measured 27 times, with a mean sample standard deviation of 3.1, does it come from a population with a standard deviation greater than 2.5? So now we don't have to do the variance. We can just do 2.5 here. So our chi-squared now is 39. So again, we're looking at a chi-squared of 0.05 and 26. So let's go ahead. Let's look at this here. Degrees of freedom. So let's go ahead and set this up. Let's calculate this. So let's look at our system here. So chi-squared of 0.05, and then we're looking at 26. So that's going to be 38. So we are slightly to the right of that, I believe. Or are we? Yep. So that is going to be that's going to be actually a reject this time. So we are to the right of our theoretical value. So that is going to be a reject in that instance. Fantastic. Now we're looking back at this. So now we need to actually do a couple of tests here. So we're going to actually do a variance test here. And the first thing we're going to do is actually a variance between, them. So this is going to be our chi-squared function. Does it come from a variance? We're looking if two systems are different. So we're going to do a chi-squared function. Let's go ahead and run this. Sorry, the video cut out there for a second. So we can actually do this var test function here if we're wanting to compare basically two different systems. So we can run our var test. You can look at it way over here. We can see those different materials. So we can run our variance test if we have essentially our data here. So we can go ahead, because we're going to look back at our data, and is the variance of 1 and 3 different? So first thing we have to do is we have to go, and then when we're using our var test, so we're still in Pset 7, and what we're going to do exactly. So we're going to actually keep that. We're going to keep this as well. Did I copy that? Yes. So we are going to read in our functions just like we did previously in Pset 4. So actually, let's go ahead and we're going to go ahead and set our working directory. We're going to set these up. Pset41, Pset4, PS41, those data files. I'm just going to drag this a little bit over here so that we can work. So we're going to set our working directory. We're going to set this, read it in, and then I'm going to do my var test, and we're seeing first, is the variance of 1 and 3 different at a 10% significance. So I'm going to do PS41, and I'm going to do 2, because if I look at, for example, PS41 bracket 2, then it's giving me all of my data sets here. Then I'm going to do here PS4 3, 2, and then we're asking, are they different? So it is alternative 2 dot sided, 10% significance, meaning a 90% confidence interval. So two-sided test. Our p-value is definitely less than our confidence interval. So that is going to fall in what for our two-sided test? That is going to be a reject H0. So we're rejecting the null hypothesis. Then we can do a greater than. So let's go ahead and pull this over here. So is 2 greater than 1 greater at a confidence level of 99 this time? So 0.99. P-value is quite small, so that is also going to be a reject, because it will be, again, still giving us that smaller confidence interval. Fantastic. It's going to fall in the reject regime. And then finally, is the variance of 3 less than 1? Oops, keep that. Variance 3 less than 1. I think it's less at a confidence interval at a 5% significance. So that means 0.95. So here we go. And then that will also be a reject. So there we go. That's our problem set. So we'll see you in the next video for our last problem set 8. See you then. Bye.